Global data travels at the speed of light, crossing oceans in milliseconds. But for human movement, the digital superhighway hits a concrete wall. This 15-kilometer gridlock at Dover represents a total processing failure. Drivers are forced to wait up to 8 hours to move goods a few miles because the system cannot handle the volume of the modern supply chain. To verify that a traveler has the right to cross a border, we rely on ink stamped onto stitched paper pages. It is a system built in the 18th century, forcing customs agents to manually inspect physical documents for millions of people every single day. We are trying to push 21st century global mobility through a bottleneck of analog paperwork. The physical passport is structurally incapable of handling the volume and speed required in the modern world. The problem starts with what a border agent is actually checking. They are asking who you are, verifying a specific name and address. But in a digital context, the much harder and much more important question is simply proving that you are a distinct, living human being. On the internet, nothing stops an automated script from generating 10,000 fake profiles. These are known as Sybil attacks. AI can easily solve security captchas, forge digital credentials, and maintain believable profiles at scale. To combat this, governments force individuals to hand over their entire biographical profile to cross a border or access a service. But stockpiling millions of names, addresses, and document numbers in a centralized state database creates a massive, highly lucrative target for hackers. Every bit of personal data gathered by these state-issued identity frameworks functions as a structural vulnerability. The act of centralizing private information builds a roadmap for future exploitation. The international community recognizes this bottleneck. The International Civil Aviation Organization, or ICAO, developed the Digital Travel Credential as a first step to replace the physical passport book. Looking at the DTC1 and DTC2 models, these credentials derive a digital companion from the physical passport chip. But notice the foundation. The government remains the central issuing authority, maintaining administrative control over the digital trust anchor. Taking a flawed analog system and putting it on a smartphone doesn't solve the underlying security risk. It simply moves the data from a physical filing cabinet to a government server. The alternative requires a different architecture entirely. In Web 4.0, systems rely on decentralized identity. Instead of a government issuing and holding your profile, you hold your own encrypted data locally, completely independent of a central authority. This infrastructure relies on a concept called proof of personhood. It is a cryptographic mechanism that confirms you are one real, distinct human being, without requiring you to hand over a single piece of identifying paperwork. It does this using zero-knowledge proofs. A zero-knowledge proof is a method of proving a claim is true without revealing the underlying data. A scanner checks your iris. The raw biometric stays securely locked inside your device. The border agent receives only a mathematical checkmark confirming your uniqueness. This biometric e-passport structure has no name or physical address under the credential claims and proof sections. Instead, there are encrypted hashes directly tied to your biological traits, anchored to a decentralized ledger that no single entity controls. Because there is no centralized database holding everyone's files, there is nothing for a hacker to breach. Stealing someone's identity under this decentralized architecture becomes a mathematical impossibility. When you apply this technology to global mobility, the physical checkpoint disappears. There's no line, no booth, and no customs officer stamping a booklet. This diagram outlines the automated workflow. Walking through a border crossing, cameras interact with your device, triggering a smart contract to match your virtual identity. It instantly verifies your proof of personhood against decentralized ledgers. The peer-to-peer transaction logs automatically, with zero human intervention. Because the trust is anchored in universal cryptography rather than a specific nation's passport agency, travelers can bypass the friction of outdated bilateral visa treaties entirely. The math proves you are a valid traveler. The system no longer cares which piece of geography issued your paperwork. It shifts the entire premise of global travel from managing national citizens to verifying global humans. Removing identity verification from state hands reduces the individual's exposure to institutional data leaks. Decentralizing this process ensures that your personhood is verified by the mathematical proofs we have established, rather than by a fragile bureaucracy. When you own your data and reveal only a cryptographic proof of your personhood, you eliminate the mechanisms that allow for mass surveillance. It is the only mathematically sound way to prevent systemic data leaks. Look at this line for passport control. Soon, the physical checkpoint and the paper passport will look just as archaic as this photograph. They are quickly becoming obsolete relics. By claiming a decentralized identifier, you transition to a model of data ownership that functions independently of the paper-based control systems we've outgrown.